linear relations and identifying them as either a direct or a partial variation. Part of what we look at with linear relations is always the slope, which is denoted by a lowercase capital M. It's indicated by the vertical change over horizontal change, change in the dependent variable over change in independent, rise over run, and the rate of change. And we do have to remember rise is going up and down like the sun does, and run goes left and right like a sprinter does. Now, if we look at all of these direct variations, if we think of the pattern or something that's common to all of them, if we look at them, none of them have the same slope because some of them slant a positive direction, which indicates a positive slope. Some of them slant in a negative direction, which indicates a negative slope. The slopes are totally different for every single one of these lines. There's only one thing that is the same for every single one of them. And that's this point here, the origin. Every single one of those lines passes through the origin. And that's what's known as a direct variation. Direct variations are always straight lines through the origin. And if I look at all of those lines, they're all linear, they all have a slope, and it's always a constant times the x value. So if I look at this red line here, if I multiply x by 2, I get the y. 1 times 2 is y. When x is 2, 2 times 2 is 4, and there's my y value. So a direct variation always shows one variable is determined by multiplying a second variable by a constant, or the value is equal to constant times position number. If we go back to some of our old terminology, or really pretty straightforward, y equals mx, where m is the slope of the line. Because if I look, the slope of this red line, my rise is 2, and my run was 1. So my slope was 2 over 1. All of these lines here, they're all different. Slopes are positive slants. Looks like all of these actually have the same slope. All of these have the same slope. The lines on the left and the lines on the right do not have the same slope, but they're all partial variations. So again, it's got nothing to do with the fact that the slopes could be the same. It's got to do with something else. So if a direct variation passed through the origin, let's find the origin. There's my origin. What do I notice about all of these lines in these graphs? Not one of them passes through the origin, and that's what makes them a partial variation. They're still straight lines, but they do not pass through the origin, and they're found by multiplying a variable by a constant and then adding or subtracting a constant. So the pattern would be the constant times the position number plus a different constant that could be positive or negative, or y equals mx plus b, which is known as the equation of a line in slope y-intercept form. Okay, slope is m, b is y-intercept. If I go back to the lines of the partial variations, if I moved all these points down 1 on this black line, the line would be the line would be a direct variation through the origin if I moved all the points down 1. Now, if I did that, let's just move them down 1, and you can see that a bit better. If I drew those points down 1, I would now have a direct variation. However, I don't. That one didn't have a direct variation. What happened to all the points? They moved up 1. And if I look at that 1, that's important, we called it the y-intercept. That's where it crossed through. And that was the difference in the equation of a direct and partial variation. That partial variation still had a slope of 2x, but all the points were moved up 1 from the origin, and that 1 represented the y-intercept. That will make no sense when you try and copy that later. That's why I'm erasing it right now. Okay, so for a direct variation, the y-intercept is 0. For a partial variation, it's never 0. If we look at some equations, we want to state the slope, y-intercept, and decide whether it represents a direct or a partial variation. So if I look at the first one, remember the equation of a line is y equals mx plus b. Now if b is 0, it's a direct variation. Is b 0 here? No. Definitely going to be a partial variation because it does not have a y-intercept of 0. And it's pretty straightforward. The slope is the number in front of x, so I need to find my x and look in front. So the slope is negative 2 over 3, and the y-intercept is what follows x, so the plus 4. So the y-intercept is positive 4, which can also be written as an ordered pair 0, 4, because remember, the y-intercept occurs when x is 0. And we said it's not a partial variation because the y-intercept isn't 0. If I look at this one here, y equals negative 2x, I've got nothing added on here. So it's a direct variation because my y-intercept is 0, and my slope, I find my x, and I look directly in front, and I see negative 2. So my slope is negative 2, y-intercept is 0, or the ordered pair 0, 0, and it's a direct variation because the y-intercept is 0. And before you come to class tomorrow, please do pages 6 to 7, number 1, 2, 12, and 13.